Okay, so let's take a look at the question 4. Write a program that will perform logical OR 0x6398 with 0x1DFE. Execute the program and comment on the results. So let's take a look at the question 4. Here is my coding for the question 4. First, we build it to see if there is any error. As you can see, there is no error, and we can start debug it. We use the mov command to store the value of 0x00006398 and store it into R0. Next, we also use the mov command to store the value of 00001DFE and store it into R1. Next, we use ORR command between R0 and R1 and store the value into the R2, which is the value is 0x00007FFE. To prove it, I use the calculator 6398 OR and 1DFE. As you can see, the value is same, which is 0x00007FFE. So let's take a look at the question 5. Write a program that copy 12 bytes of data starting from memory locations 0x4004000H to program location starting 0x40040020H. Set manually the content of memory in 0x40004000H until 0x400400BH to be 0x01, 0x02, and so on. Run the program and comment on the result. So let's take a look at the for the coding for the question 5. So this is my coding for the question 5. Let's be able to see if there is no error. If there is no error, we can start debug it. Before we start the simulations in the arm kill, we will set the value manually at this. Then we step down the cursor line and we step in. For the value 0x40040000, we use the identical command to store the value that I talked about and store it into the R0. Next, same as this R1, we store the value of 0x400400020 and store it into R1. Sorry, for the next R0 and this R1. Okay, so the R2 has the value of 0x000004. Next, we use the LRB to store data of 0x000001 into the R3, and the R1 R0, sorry, the value change from 0x40040000 into value of 0x40040001 because we use the step 1 counter. Next, we use SRB, also same as this one. The R1 change from 0x40040020 into the value of 0x40040021. Then we sub R2, the value change into 0x000003, and then we compare value in R2 with 0. As you can see, the value is 3. So the coding will go to the BNE, which is lagi, and it will loop into the lagi and start back at LDRB until it found the value of 0. As you can see, the RT, as you can see, the R2 has the value of 0x000002, but it is not 0, so it will start back again from the line of LDRB until it get 0. After it get the value of 0, the loop is N. You can see the memory address also change this. So let's take a look at the last question. Write a program to compare data in num into register R2. If the data is greater than 5, store the data in memory location 0x400 to 0000. Otherwise, add the data with 0x60 and store it in memory location 0x400 to 0010. Before that, set the number with value 3, use ECE instructions, run the program and comment on the result. So this is my coding for the last question in laboratory works. Let's reverse, and there is no any error. We can start debugging. The value of 0x400 to 0000 we store in R0 because we use the LDR command. Same as the R1, we use the LDR command to store value of 0x400 to 0010 and store it R1. And then the R2, we have the value of 0x00000005. Next, the R3 also have the value of num, which is I have the use the equation instruction, EQ instruction, which is 3. So the value of R3 should be 0x000003. And then the next command is compare between R3 and R2. If R3 if R3 is greater than the R2, the coding will go to this and store the value of R3 into the R0. But if the R2 is lower than the R2, it will go to this line. As you can see, we use the add command. So R3 still the same, but the R4 change into the value of 0x00000063. And next line is use the str command to store the data from R4 into the R1. As you can see here, the data from the R4 will put in the memory location of R1. Okay. For the conclusion, to conclude that the student able to write simple assembly language problem for the ARM microcontroller using data transfer and data processing instructions and addressing modes. Student also able to execute the program using ARM kill software and use the simulator. Student also able to use theory that student have learned from the lecture, which is the addressing mode, arithmetic operation, logical operation, branch and loop operations to use in the ARM kill software. So and student also learn to use properly and the perfect coding for the lab, so that the simulation of ARM-Kill software can run smooth and no any other error occurs. So that's from me. Thank you for listening and goodbye. Assalamualaikum.